Good day, students. Welcome to this JSS 1 Basic Technology lesson on measurement tools, focusing on the ruler and set square. Accurate measurement is the cornerstone of all practical technology work. A door that is 2 mm too wide will not fit its frame, a shelf bracket that is not square will make the shelf tilt. In this lesson we go deeper into the instruments you will use every day in the workshop and drawing class. By the end of this lesson, you will be able to use a steel rule/ruler correctly to measure to the nearest millimeter, use a tri-square/set square to check and mark right angles, use a combination square and marking gauge, read vernier calipers and micrometer screw gauges at introduction level, and apply correct measuring technique to avoid parallax and other errors. Let us begin. Why accurate measurement matters. In technology and engineering, dimensions must be precise. Tolerances define the acceptable range of variation. In basic woodwork, plus or minus 1 mm may be acceptable. In engineering, plus or minus 0.01 mm may be required. The correct instrument must match the precision needed. Unit: in technical work, length is measured in millimeters, mm, for small dimensions and meters, m, for larger ones. Avoid mixing units in one calculation. The steel ruler. A flat metal strip marked with millimeter and centimeter graduations. Why steel rather than plastic? Steel rules are more durable and do not warp or flex. Correct use. Place the rule flush along the workpiece edge, not balanced on its edge. Read the measurement at eye level, looking straight down to avoid parallax error, the apparent shift in a scale reading when viewed at an angle. Measure from the 10 mm mark, not the 0 end which may be worn, and subtract 10 mm, avoids inaccuracy from a damaged or worn end. Mark measurements with a sharp pencil or scriber, do not use a thick crayon or biro which creates wide, inaccurate lines. Parallax error occurs when the eye is not directly above the scale graduation. Always read measurements from directly above, perpendicular to the scale surface. Parallax is a common source of error in amateurs' measurements. The tri-square. A tri-square, also called a carpenter's square or engineer's square, consists of a stock, thick handle, held against the reference edge of the work, and a blade, thin flat ruler, extends across the work face at 90 degrees to the stock. Uses: checking that an edge or face is truly flat and square, perpendicular, marking lines at 90 degrees to an edge, checking that a corner is truly 90 degrees. Correct use: hold the stock firmly against the face edge, the straight, true reference edge, the blade lies across the work, mark along the blade. Checking for square: place stock against edge, if light shows between blade and work surface, the surface is not truly square. The combination square. More versatile than the tri-square, has a sliding head on a ruled blade. Can measure at 90 degrees, like a tri-square, 45 degrees, miter, and read depth of rebates. The sliding head can be locked at any position along the blade for measuring equal depth along a workpiece. Also has a spirit level built in, for horizontal/vertical checking. Used in metalwork and woodwork marking. The marking gauge. Used to mark a line parallel to an edge of wood. Has a stock, wooden fence that slides on a rod, an adjustable spur or sharp pin, and a locking screw. Set the distance from stock to spur equals the distance from edge to mark. Lock. Holding the stock against the face edge, push or pull the gauge along the work, the spur scratches a parallel line. Used extensively in marking out joints, especially having and mortise and tenon. The vernier caliper. Introduction. A precision measuring instrument for measuring external diameter, outside jaws, internal diameter, inside jaws, and depth probe/rod. Reads to 0.1 mm, basic vernier, or 0.02 mm, fine vernier. The main scale gives readings, the vernier scale, or 0 to 9 divisions, gives the fractional reading. Reading: note the main scale, just before the 0 of the vernier scale, then find the vernier scale line that aligns with any main scale line, add these readings. Example, main scale equals 23 mm, vernier line 7 aligns total equals 23.7 mm. The micrometer screw gauge, introduction. Even more precise than the vernier caliper, reads to 0.01 mm. Used for measuring small diameters and thicknesses, wire, sheet metal, small machine parts. Parts, anvil, fixed, spindle, or moves with the thimble, rotating sleeve, or main scale, ratchet stop, applies consistent pressure. Reading, sleeve scale, 0.5 mm intervals, thimble scale, 0 to 50, each division equals 0.01 mm. Example, sleeve equals 6.5 mm, thimble equals 17, total equals 6.5 plus 0.17 equals 6.67 mm. 3 examination questions. Question 1. A student measures the same length with a steel rule and gets different readings, 35 mm and 36 mm, on 2 attempts. Give 2 reasons this might happen. A. Parallax error. On one attempt the eye was not directly above the graduation, the scale appeared shifted. Always look straight down from above. B. Inconsistent measuring position. One reading started from the 1-0 end of the rule, the other from the 10 mm mark, subtract 10, giving a 1 mm discrepancy. Always measure consistently from the same reference. Question 2. Explain the correct procedure for checking if a corner of a wooden board is truly square using a tri-square. Step 1. Identify the face edge, the straightened, true reference edge of the board. Step 2. Hold the stock of the tri-square family and flatly against the face edge, with the blade lying across the face of the board. Step 3. Look for any gap between the blade and the surface at the right angle position. Step 4. Alternatively, hold the work against a light source. Any light visible between the blade and the corner surface indicates the corner is not at 90 degrees. Question 3. A vernier caliper main scale reads 14 mm and the 4th vernier division aligns. What is the measurement? 14 mm plus 0.4 mm equals 14.4 mm. 3 common mistakes. Mistake 1. Measuring from the 1 end of a steel rule. The 0 end of an old rule is often worn, bent, or indented. This introduces error. Professional practice is to measure from the 10 mm or 50 mm mark and subtract. Never assume the 0 end is accurate. Mistake 2. Reading a vernier caliper from the wrong scale. The vernier caliper has 2 scales, main, mm, and vernier, fractions. Students sometimes read only the main scale and get a whole number answer. The vernier scale must also be read to get the decimal fraction. Mistake 3. Pressing the stock of the tri-square against a rough or curved edge. The tri-square is only accurate if its stock lies against a flat, straight reference edge. If the edge is rough, curved, or has a bump, the stock will tilt and the square will give a false reading. Always check the reference edge for straightness before using the tri-square. Summary. Measurement accuracy, parallax error, always read directly above, measure from 10 mm mark not 1-0 end, use sharpened pencil / scriber for marks. Steel rule, measures length to nearest 0.5 mm, tri-square, carpenter square checks and marks 90 degrees angles, stock against face edge, check for light gap. Combination square, 90 degrees plus 45 degrees plus depth measurement plus spirit level. Marking gauge, marks a line parallel to an edge, set distance, log spar, scribe along the walk. Vernier caliper, measures to 0.1 mm, or 0.02 mm, external / internal diameter plus depth. Read main scale then vernier scale, add together. Micrometer screw gauge, reads to 0.01 mm, sleeve scale plus thimble scale. Precision increases, ruler combination square caliper micrometer. For homework, A. Explain parallax error and how to avoid it. B. Read vernier caliper if main scale equals 22 mm and vernier 6th line aligns. C. Draw and label a tri-square. Attempt a quiz on your LMS. Measure twice, cut once, always. Visit Litech Academy at academy.litech.com.ng. Until next time.